Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Welcome to the Deep Dive. Today we're jumping straight into MATLAB.
MATLAB.
Yes. If you're working in engineering or science, you probably run into it. It's kind of a powerhouse, isn't it?
It really is. And the name itself, MATLAB, well, it stands for Matrix Laboratory.
Right, Matrix Laboratory. That tells you a lot straight away.
Exactly. It really highlights its main strength, handling matrix computations really efficiently. Think of it like a high-level calculator and coding space rolled into one, specifically for technical folks.
So our mission today really is to unpack what MATLAB is, why it's such a big deal in these fields, and where you actually see it being used.
Sounds good. And it has quite an interesting backstory, too.
Oh, yeah. Tell us a bit about that.
Well, it goes back to the late 1970s. A guy named Cleve Moeller, he was at a university.
Okay.
And he basically developed it to give easier access to some fundamental math software libraries, things called LinPack and IcePack.
So tools that were maybe hard for researchers to use directly back then.
Precisely. He wanted to make matrix math more accessible, less cumbersome. And that user-friendly interface he created, it just took off.
I can imagine. So it spread through universities first.
Yep, academia loved it. And then it moved pretty quickly into industry. Now, of course, it's a commercial product from MathWorks, and it comes with all these add-ons, these toolboxes.
Toolboxes, right. We should definitely touch on those. But first, let's pin down what is MATLAB fundamentally.
Okay, so at its heart, it's two things. A high-level programming language and an interactive environment.
Interactive meaning you can just type commands and see results immediately.
Exactly. You can run commands one by one, test things out. But you can also write full scripts and functions. Its big advantage is simplifying operations on matrices and arrays.
So like solving complex math or engineering problems without getting lost in the weeds of low-level code.
That's the idea. It has loads of built-in functions for things like linear algebra, signal processing, optimization, stuff that would take ages to code from scratch.
And the plotting. The visualization tools are pretty impressive too, right?
Oh, definitely. Creating graphs, 2D, 3D plots, it's very powerful for actually seeing and understanding your data. Helps a lot with interpretation.
Makes sense. And you mentioned scripting in apps, so it's not just for quick calculations.
Not at all. You can automate complex workflows, build custom tools, even develop standalone applications, all within the MATLAB environment.
Okay, so it's clearly capable. But why MATLAB? Why has it become such a standard in engineering and science when there are other languages, like Python, for instance?
That's a really good question. I think a big part of it is that specialization we talked about.
Tailored for those fields specifically.
Right. The libraries, the toolboxes, they're designed for the kind of complex mathematical modeling and simulation engineers and scientists do every day. It's like having a specialized toolkit ready to go.
So it saves time, basically.
Huge amounts of time. And there's the ease of use factor, too. The syntax is generally simpler than some other languages, especially for mathematical operations.
Letting people focus more on the problem itself, maybe.
Exactly. Less focus on complex programming, more on solving the actual engineering or scientific challenge. Plus, the visualization we mentioned, that's not trivial. Good plots are key.
And the toolboxes seem critical. Can you give an example?
Sure. Like, there's a control system toolbox, a signal processing toolbox, even ones for machine learning and deep learning now. These contain pre-built, verified functions for really specific tasks.
So you don't have to reinvent the wheel every time.
Precisely. And then there's just its strong adoption. It's widely used in major industries, aerospace, automotive, finance, plus its deep roots in academia.
Okay, let's talk applications. Where would someone listening encounter MATLAB, maybe without even knowing it?
Well, it's huge in academic research, obviously, and teaching technical concepts.
Yeah.
But industrially, think control systems for robots or autonomous vehicles.
Okay. Simulating how they'd behave.
Exactly. Modeling, simulation, even rapid prototyping. Also, signal processing, analyzing audio, medical signals, communications data. Image processing is another big one.
And finance. You mentioned finance.
Yep. Quantitative analysis. Building complex risk models, developing algorithmic trading strategies. And aerospace and automotive use it heavily for designing and testing complex systems.
So it's really embedded in a lot of high-tech development.
Definitely. From designing flight controls to analyzing financial markets to processing MRI images, it's oft working behind the scenes.
It sounds almost perfect for its niche. But Are there downsides? Any considerations people should keep in mind?
Yeah, absolutely. Nothing's perfect, right? The biggest one is probably cost.
It's commercial software.
Right, it's proprietary. And the licenses, especially with multiple toolboxes, can get quite expensive. That can be a barrier, particularly for individuals or smaller companies.
Okay, cost is one. Anything else?
Performance can be an issue in some very specific cases. For extremely heavy number crunching tasks, sometimes a compiled language like C++ or Fortran might be faster.
Because MATLAB is often interpreted, at least partly.
Sort of, yeah. It has just-in-time compilation now, which helps a lot, but there can still be overhead compared to fully compiled code. And lastly, it's not really a general-purpose language.
You would build a website with it.
Exactly. It's fantastic for numerical computing, data analysis, visualization, but not for, say, web development or general IT tasks.
So it knows its strengths and sticks to them. What about the future? Is it going to stay relevant with things like Python growing so rapidly?
I think so, yes. MathWorks is constantly developing it, adding new toolboxes, improving performance, and integrating things like AI and cloud computing.
Cloud integration must make it more accessible, too.
It does. It helps with managing licenses and handling really large data sets or simulations. Given its huge existing user base and how deeply embedded it is in industry and academia, I think it's definitely here to stay.
Okay, so let's try and sum that up. MATLAB is this powerful, pretty user-friendly environment tailored for numerical work.
Right. Matrix-based, great for math, science, engineering.
Its power comes from that matrix focus, the specialized toolboxes that save a ton of time, and really strong visualization tools.
Couldn't have said it better. It provides a really solid platform for tackling complex technical problems.
All right, here's the thought to leave you with. We know MATLAB is huge in industry, and it keeps evolving. Thinking about the future, how might big advances in cloud computing and, say, artificial intelligence further integrate with platforms like MATLAB? How could that change the game for simulations and data analysis for technical pros like you?
That's a fascinating question to ponder.
Something to think about. Thanks for taking this deep dive with us today.